In this video, we're going to go over how to graph secant and cosecant and their transformations. Since we know that secant x is equivalent to 1 over cosine x, we know that we cannot have 0 for our denominator, so we're going to put vertical asymptote for cosine x is equal to 0. And we're going to use the max and min of cosine in order to graph secant x. Therefore, only the red part of the graph should be the graph of secant x. For cosecant x, we know that that's equivalent to 1 over sine x. So our denominator cannot equal to 0. And we have 3 asymptotes here using the sine graph, max and min. We have a graph of cosecant x, which is in red. So for our example, we're going to graph 2 cosine 3x minus pi first. So I'm going to set what's inside of the parentheses in between 0 and 2 pi at pi on both sides. Divide 3 on both sides. And we know that that's our starting point, our end point. And let me do the rough sketch of cosine. And this should be pi over 3. And by looking at the amplitude of cosine, it will be 2, -2. But don't forget, we don't have amplitude for secant because we don't really have max and min divided by 2, right? And we can find our period by taking the difference of these 2 points. 2 pi over 3 should be our period, or you can use 2 pi over b, which will give you 2 pi over 3 as your period. And we can find our vertical asymptotes. For secant, and we can graph by using max and min of cosine. I'm going to erase the red part of the graph because only the black part of the graph is 2 secant 3x minus pi. And in order to identify these points, we know that it will be pi over 3, 2. And every quarter of the way, we had our key points for regular cosine x. So I'm going to do the same thing to locate where my asymptote and the key points are. So I'm going to add pi over 6 to pi over 3, which is basically, I'm going to make a least common denominator. We have asymptote at 3 pi over 6. And then to 3 pi over 6, I'm going to add pi over 6 again. Then we get 4 pi over 6. So that's one of the key points. And then to 4 pi over 6, I'm going to add pi over 6 again. Then at 5 pi over 6, we have another asymptote. And to 5 pi over 6, I'm going to add pi over 6 again, which is 6 pi over 6. And is that pi? Yes, it is pi. So that point should be pi, 2. Now let's look at the graph of y equal 2 cosecant pi x plus pi over 3. I'm going to use sine graph in order to graph our cosecant graph. So first step, I'm going to set what's inside of the parentheses in between 0 and 2 pi minus pi over 3 on both sides. Divide by pi on both sides. So my starting point for sine should look like this, right? It starts at -1/3, and we have another point there, and we have asymptote. So we don't have a point, but we have asymptote at -1/3, another asymptote, and another asymptote. So let's put -1/3 and 5/3, and then let's find the asymptote that's in between -1/3 and 5/3. You can take the midpoint of these two, or you can use a quarter wave, right? So let's find our period, which is 5/3 minus -1/3. This is equal to 2. That's our period. So period divided by 4 tells us the key point, so which is equal to half. And make a least common denominator with the -1/3. That will be equal to -2/6 plus 3/6, which is equal to 1/6. So this will be 1/6, comma, 2. By looking at the amplitude of 2 sine, πx plus π/3. And then to 1/6, I can add another 3/6. That will give you 4/6. So we have another vertical asymptote at 4/6. And then add another 3/6 to our vertical asymptote, which is 7/6. And that's -2 by looking at the amplitude of sine. And then 7/6 plus 3/6, which is equal to 10/6. And is this equivalent to the last asymptote? Yes, so we did it correctly. But then I want to graph my two cosecant πx plus 3. So only the blue part and vertical asymptote part should be a graph of 2 cosecant of πx plus π/3 graph.